Okay, guys, so today we're going to look at parabolas as a function, and we're going to focus on one type of modeling of a quadratic, which is projectiles. So I'm sure you've heard of projectile vomiting. I'm sure you've seen balls be thrown and the arc that they make. If you've ever played Angry Birds or any of those basketball games, you'll notice that it does a dotted line to show you the path of the parabola. You've also probably seen a video from time to time where a man will walk up a very tall ladder and then free fall into or jump up and fall into a very thin amount of water, small, shallow amount of water, and know the exact distance that he would land. Those things don't just happen by happenstance. No man is going up, like 25, 30 feet and just free falling and hoping that he lands in that pool. So there's math behind all of this. I love teaching this in person. We really, everybody gets to kind of toss things and free fall things, and we watch the path of it all. But being that we're at remote learning and I'm trying to reduce unnecessary work for you, I'm going to show you portions of different videos. So in this video so far, they're talking about a punter who has a very perfect kick. So I want you to just first off watch a little bit of this and try to understand the forces that are pulling on an object. So there'll be a vertical height, there'll be a horizontal distance. As a ball or an object gets thrown up into the air, it will actually stop and then it will start to then descend. And you've seen this millions of times when you're out playing soccer, when you're throwing a ball. There's a moment where there's a stopping point. That moment will be the turning point on that function. Now, most of these are, real life situations, so you'll see that we have lead coefficients of negatives on a lot of these, because when things get thrown up, gravity pulls them back down. So they'll have maximums. So the lead coefficient is generally negative. With the force of gravity, it does force that initial coefficient to be -16. When you get into physics, you'll understand the genesis of that coefficient. But you'll note that that becomes part of, if we're in feet, that will become part of the standard formula for any projectiles. So anytime something is thrown, it has its natural restrictions. So it's going to be a base quadrant 1. You're going to have to account for height, so your y-axis will likely be increased. Things that are thrown in the air don't stay in the air for extremely long periods of time, usually seconds. So if we're doing a feet per second, the time would be in seconds. And you'll note that sometimes between like 3 and 8 or 9 seconds is generally a time frame, anywhere from really like 1.5 to about 8 seconds, depending on the distance of a kick or a throw or any